Algebra 2, right triangle trigonometry. Concept 33. This concept is going to extend the right triangle information that you learned in geometry. And I have broken this into 3 parts. So in this first part, we're going to be focusing on the trig functions, sine, cosine, and tangent. And then we're going to add 3 new ones, which you may or may not have learned in geometry. So the first thing to realize is that we are working with solely right triangles. In the following concepts, we'll deal with triangles that are non-right triangles. But right now in this entire concept 33, all 3 parts, we're talking about right triangles. So some right triangle ratios, which means the comparison of 2 side lengths by division, are used so often in problems and, to solve for sides and angles that we've given them specific names. And those names are sine, cosine, and tangent. Now we have 3 new trig ratios. Also, we have cosecant, secant, and cotangent. So if you look at this chart, you'll see the right triangle definitions of the trigonometric, or we call them trig functions. I will usually use the term ratios mostly rather than a function. So we've got the sine of theta equals the side that is opposite compared or divided by the length of the hypotenuse. So again, remember that this is talking about in a right triangle. So I'm going to draw a right triangle here, and I'm going to label one of the angles theta. Now the side that is opposite theta, so you put your eyes right in the middle of the angle and look directly across. It is the side that is formed by the angle, the edges of the angle theta. That is opposite. The hypotenuse is always across from the right angle. So the sine ratio of theta would be the length of the side that is opposite divided by the length of the hypotenuse. Now I just went ahead and put some random numbers in for this right triangle. So we have legs of 3 and 4 and a hypotenuse of 5. So the sine of theta is the length of the opposite side, which is 4, over or divided by or compared to the length of the hypotenuse, which is 5. The side that touches the angle that's not the hypotenuse, we call that the adjacent side. It's next to it. And so in this triangle, that is a length of 3. So the cosine of theta would be 3 over 5. And then the tangent is the comparison of the side that's opposite divided by the length of the side that is adjacent. So again, in this triangle, with theta labeled where it is, it would be 4 over 3. Now the sides that are opposite and adjacent depends on where you label the angle. So now in this triangle, if I label the other angle theta, that means the side on the bottom is opposite because we always talk in terms of an angle. Hypotenuse is always across from the right angle, and the adjacent is the side that touches the angle you're talking about that's not the hypotenuse. Now let's look at the other trig functions, and I put them in the table purposely. They're located where they are. So underneath the sine is cosecant, and it's just abbreviated CSC, but the entire word is cosecant, and it is just a reciprocal function. Sorry. Notice it is the hypotenuse divided by the side that's opposite. With cosine, it's secant, and with tangent, it's cotangent. Now, those are written up above, and then I'm going to write them in below, and you can do that too on your notes. So cosecant, you can always abbreviate CSC, but we always say the entire word. Secant, we always abbreviate that as SEC, but we say the entire word when we read it. And then cotangent. Finally, there's a good acronym to help you remember sine, cosine, and tangent. So it is SOHCAHTOA, and this is how I write it. So I write S and then the O on top of the H. So it reminds me that sine is the opposite divided by or over the hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOHCAHTOA. All right, let's look at this example. So it says find the trig ratios given two sides of a triangle. And notice it's a right triangle. Also, remember the Pythagorean theorem. A squared plus b squared, which are the legs, equals the hypotenuse squared. Find the 6 trig ratios given two sides of this triangle. Well, we need to know the hypotenuse to do that. So we can use the Pythagorean theorem to set up an equation. So 5 squared plus 12 squared will equal our missing length. We'll call it c squared. 25 plus 144 is c squared. Adding those together, 169 is c squared. And then let's take the square root of both sides. So our hypotenuse is a length of 13, and let's label it. Now we know all the sides of this right triangle, and we can find all the trig ratios. Put your eyes on angle theta, and we're going to write the sine ratio, which is the side that is opposite compared to the hypotenuse, 12 over 13. Now we're going to drop directly underneath and find the cosecant, which is easy. It is just the reciprocal of sine. So you're just going to flip it, 13 over 12. Now let's look at the cosine. So the side that is adjacent is 5 and the hypotenuse is still 13. So that's our cosine. And now to find the secant, we'll just flip that ratio. Tangent, we're looking for the side that is opposite. So I'm drawing those arrows for you, looking directly across compared to the side that's adjacent. So 12 over 5. And now to find the cotangent, we just flip that. So that's all we're doing right now. We're just practicing finding and writing those ratios. And soon we're going to use those to solve problems and find lengths and angles. Look at example 1b with me. We want to find these 6 trig ratios again, but we need all 3 sides of a triangle. So let's set up the Pythagorean theorem. 3 squared plus 4 squared equals c squared, because that's our hypotenuse. 9 plus 16 is c squared. 25 equals 6c squared. Take the square root of both sides. So c equals 5. This is a good, what we call a Pythagorean triple, 3, 4, 5. So if your legs are 3 and 4, your hypotenuse will always be 5. So now put your eyes on angle theta, and you're going to look opposite, which is 3, and the hypotenuse, which is 5. So that is our sine ratio, 3 over 5. The cosecant of theta is the reciprocal, 5 over 3. Put your eyes back on theta and look at the side that's adjacent. So the side that touches it, that's not the hypotenuse, and then over the hypotenuse. So the cosine of theta equals 4/5. The secant of theta is 5/4. And now finally the tangent. Put your eyes back on theta again and look directly across, 3 over 4. And then the cotangent of theta is 4/3. I should have mentioned that often for angles, unknown angles, you'll see Greek letters used in math problems. And so this is a very common Greek letter. It's the letter theta. All right, on this next problem, again, we need to find the third side, but notice it's a leg. So we're going to say 15 squared plus b squared equals 17 squared. So 225 plus b squared equals 289. Subtract that value. B squared is 64, so that means b has to be 8. Now we know everything we need to know to write these 6 trig ratios. Again, this is all we're practicing. Put your eyes on theta, look opposite, and then find the hypotenuse. So it's 15 over 7, and then the cosecant of theta is the reciprocal of that, 17/15. The cosine of theta is the side that's adjacent over the hypotenuse, 8 over 17. And then the secant is the reciprocal of that. Put your eyes back on theta and look directly across for the side that's opposite, which is 15, and then the side that is next to it touching theta but is not the hypotenuse, which is 8. And then the cotangent of theta is 8 over 15. All right, hopefully you're getting good at this, feeling comfortable. Maybe you're remembering this from geometry. All right, so look at this triangle. So you might recognize something special about these measurements, but we're not going to talk about that in part 1. We're just going to use the Pythagorean theorem to find the third side. But you may remember that this is a special right triangle, and you may already know what this third side is. So that would be 25 plus b squared. When you square 5 square roots of 2, you get 5 times 5, which is 25, times 2, which is 50. Subtract your 25. You'll get b squared equals 25, so b equals 5. So notice our legs are the same. Put your eyes on theta. Look at directly across, so the side that's opposite, which is 5, over the hypotenuse, which is 5 over the square root of 2. Ooh, that is so small. So now let's simplify. So what I'm going to do is I'm dividing my 5's out. So I get 1 over the square root of 2. And then I'm going to rationalize. Multiply top and bottom by the square root of 2. So our final rationalized answer is the square root of 2 over 2. Now for the cosecant, I'm going to go back to my original ratio, which is 1 over the square root of 2, and I'm going to flip it. So I have square root of 2 over 1, but I don't need to write that 1 in the denominator. All right, cosine is going to be the exact same thing because those numbers are the same for us. So I'm just going to write them in already simplified. Finally, look back at your triangle. Now put your eyes on theta. Tangent is the side that is opposite over the adjacent. So 5 over 5, which reduces to 1. Reciprocal of 1 is 1. All right, and you're probably catching on that we are not leaving these in decimal form. We're not estimating. We're leaving them in fraction form. And if we have a radical in the denominator, we're going to rationalize. Okay, so look at this one. It says use the Pythagorean theorem to find the missing side of the triangle length. Then use that side length to find the other 5 trig ratios. So the sine of theta equals 4/7. Remember, we're talking about a right triangle. So draw a right triangle. Label one of the angles theta, not the right angle, one of the other acute angles. And then label the side that is opposite 4. And then label the hypotenuse 7. Now you can see you're missing a leg. So let's set up an equation using the Pythagorean theorem. So 4 squared plus b squared equals 7 squared. 16 plus b squared equals 49. Subtract your 16. So b squared equals 33. B then is the square root of 33. We're not going to estimate. We're going to leave this in exact terms. All right, now we're ready to find all of these 6 trig ratios, and we're going to do some rationalizing with this square root of 33. So for the sine, put your eyes on theta, then look directly opposite, which is 4. Oh, plus we were given that, so we can just write it in. 4/7, and then the cosecant is 7/4. Now put your eyes on theta. For the cosine, you're going to look to the adjacent side, which is the square root of 33 over 7. And that's just fine. We can have a square root in our numerator. When we flip that, however, we need to rationalize. So we end up with 7 square roots of 33 over 33. Now for the tangent, it is opposite over adjacent. So 4 over square root of 33. Rationalize. So 4 square roots of 33 over 33. And now for cotangent, go to your original ratio and just flip it. And you'll get the square root of 33 over 4. Again, just practicing finding all those 6 trig ratios. All right, look at this one. In a right triangle, theta is an acute angle and the cosine is 7/10. So I bet you know what to do. Draw a right triangle, label an angle theta, and then the cosine is 7/10. So that means the side that's adjacent to that angle is going to be 7, so label that. And then the hypotenuse is 10. Now you can see that you need to find the other leg. So set up an equation. So you'll get 49 plus b squared equals 100. B squared will equal 51. And b is the square root of 51. I'm going to erase some of this work so I can label the triangle clearly. All right, let's fill in what we know. So we know that the cosine, we were told, is 7/10, so the secant is just 10/7. Now put your eyes in the triangle on theta, and then take the side that is opposite, 51 over the hypotenuse, 10. For the cosecant, you're going to flip that and then rationalize. So multiply top and bottom by the square root of 51. So if you can't see that, that is 10 times the square root of 51 over 51. Now for the tangent, put your eyes on theta, and it is the opposite over the adjacent, square root of 51 over 7, and then flip it and rationalize. Multiply the top and the bottom by the square root of 51. All right, that concludes our Concept 33 Part 1 notes dealing with all 6 trig ratios.